we had an electrical energy to mechanical energy, right? So that
Yes,
was
sir.
conversion from electrical energy to mechanical energy. Okay. So that was the conversion. Now, basically, first of all, we will complete the potential energy. We need to understand potential energy, and it can be applied to various concepts. A number of concepts can be applied to potential energy, and the potential energy shortened as PE and generally represented by the symbol U. Okay, potential energy, it's generally represented by the symbol U. So how do we define potential energy? We define this potential energy as energy possessed by a body. It is defined as energy possessed by a body energy possessed by a body due to its shape, configuration, okay, or position. So we observe that in various substances, whenever there is a change of shape, or there is a change of configuration, or there is a change of position, so there is some ability to do work. That substance gains some ability to do work. For example, if we consider a stretched spring, so let us consider first a spring, and if we stretch it to a certain length, let's say it has some mass tied to it, and we have stretched it to certain extension, we have produced some amount of extension in it by applying some amount of force on it, right? So in this case, now what has been changed for the spring? We have changed the shape of the spring, right? And in changing the shape of the spring, this stretched spring, it has gained some energy, it is able to do some work. So if you release the mass from its position, the mass will move in the backward direction towards its mean position. Okay. So the mass will move towards the mean position. It will enter over here towards the mean position, right? So as we see that there is a change, there is an energy. That is why it is doing some work. It is making this mass displace from its position, this which is extreme position to the mean position, right? So this amount of energy with this which the spring has is the potential energy of the spring. Okay. The similar thing we observe when there is a change of when there is an energy, you also observe a change of energy in the case of a bow, a stretched bow. So if you observe a stretched bow, so in the case of stretched bow, what do we observe? You have a stretched bow, and in this stretched bow, there is a change of shape, and because of the change of the shape of this strip of the article of which it is made up of, since there is a change of shape, so therefore it possesses potential energy and it has the ability to do work. Therefore, it displaces the arrow from this position to a certain distance, right? So in all these cases, we observe that the substance has a potential energy. Similarly, you have observed with the help of balloon also. Suppose you inflate a balloon, so the balloon has air in it. Okay. Now, so it should be able to do some work, right? So if you open up from here, air will move out of it, and hence you will observe that the balloon starts moving in the forward direction. Okay. So the balloon is making some displacement. There is some amount of work done by the balloon. Okay. So that work done is also due to the potential energy of the balloon, which was again due to change of shape of the balloon, right? So I hope you have understood all these cases where there is a change of shape. A stretched rubber band. A stretched rubber band also has potential energy stored in it. Okay. Now the other situations, for example, let us consider here. Suppose we consider this to be the ground level, and from the ground level we try to lift some amount of any substance to a certain height h. Suppose to a certain height h, we have we start some object. Let's say we have a ball or some stone of mass m, okay, which is lying on the ground. Now, if we lift it to a certain height and raise it, position it over here, so therefore we observe that it has changed its position. Okay, by the change of position, is it able to do any work? So the answer is yes. This ball, which is now at a height h, it has a potential energy stored in it due to change of its position. So due to the change of position, the ball has reached a height h, and uh, therefore it has some amount of potential energy at this point. Okay, and hence when it is released from this point, suppose the support is removed from here. If the support is removed from here, so the ball will displace on its own, as it has potential energy stored in it, right? So I hope you have, all of you have understood the concept of the potential energy. Okay, everyone has understood what is potential energy. Wherever you see a change of shape or a change of position, so in all these situations, we observe a, in all these situations we observe a change of potential energy, or the object gains some potential energy, because of which it is able to do some work, because of which we are able to obtain some amount of work done, right? Now, to calculate the potential energy, how do we calculate the potential energy? Okay, so how do we compute, how do we measure the potential energy? To measure the potential energy for your grade 9, for class 9, we do not have to measure the potential energy of spring. We do not have to measure the potential energy of balloon. Also, we don't have to measure the potential energy of stretched bow, as however they are possessing potential energy, but their mechanics of study is quite different. Okay, it is different from what is happening over here in the case of gravitation. Okay, so basically we will be studying potential energy due to gravitation, and we call that as gravitational potential energy. So for your grade 9 or class 9, we will be mainly studying with gravitational potential energy, right? Okay, so any doubts to anyone? Anyone has any doubt? Yeah, Abhinav, any doubt?
No, sir.
Okay, so let's say the measurement of the potential energy. How can we measure the potential energy? So measurement of potential energy. How can we measure the amount of potential energy? Okay. So here we basically utilize a concept that is known as a work energy theorem. We will also study that concept of work energy theorem later in this chapter, but we are going to utilize it right now. Right now we are going to utilize the work energy theorem. The work energy theorem, it states that Wait 1 minute. Okay, so let's see the measurement. How to measure for the potential energy. See, according to the work energy theorem, we are going to utilize here the work energy theorem. And what does the work energy theorem say? According to the work energy theorem, whatever amount of work we do, our work done, it gets stored in the form of potential energy. Or in other ways, you can understand it the reverse way also. Like whatever amount of energy you have, that same amount of work can be done. Okay. So work and energy, they are interconvertible. Okay. So we are going to use that, and using that, first of all, let's say we have some mass m. Okay. So we have a mass m, and we want to lift this mass from ground position to a certain height h. So we want to lift it to a height h. Okay. Let's say this is the height h, and we want to lift this to height h. So as per the work energy theorem, whatever amount of work we do in lifting this mass from this position to the height h, our work done will be stored here in the form of potential energy. Okay. So how are we going to do work? See, suppose how are we going to do work? As the mass is on the ground. Okay. So there is a force acting on this mass. Can you name the force which is acting on this mass?
Gravity.
Gravity. Okay. And is there any other name for that force?
Acceleration due to that.
No, that is acceleration. That is a different acceleration and force are not the same. Okay.
Can you repeat
So
it? No,
what?
sorry, sir, nothing.
Okay. So this is the gravitational force or the gravity. I'm asking, is there any other force, any other name of this force which is acting on this mass?
Friction.
Friction. No, I'm going to lift it up. So I'm just asking another name for gravity. Think, it's very easy. You are not just going, you are not able to rotate your mind. It's very easy. You have heard that word many times. You have used that word many times. Okay. So shall I tell then? I think none of you are able to get it. Okay. So can anyone define me weight?
Acceleration mass
Mass
into
into
gravity.
gravity.
Mass into but the
Mass into
definition
acceleration due to gravity.
mass into acceleration due to gravity, that is of course the weight. We get weight by the formula mg, which is mass times acceleration due to gravity. But have you searched what is the definition of weight? How do we define weight? Yes, anyone can tell? How do we define that? Define the weight.
Mass of an object influenced by gravity. Like
No, it's the force with which it is defined as the force with which gravity pulls an object. So the force with which gravity pulls an object. Okay. The force with which gravity pulls an object is called weight. So this is the definition of. So how do we define weight? It is the force with which gravity pulls an object. Okay. So with what force the earth will pull an object? The formula of the force is given by mass into acceleration. The formula of force is given by mass into. Yes, and mass is m. The acceleration is you get weight as mg, right? So this force with which this object is being pulled towards the earth, this is also called as the weight of the object. एक मैसेज नहीं किया पढ़ाई कर लो तैयारी कर लो सब okay, so understood this? Just wait for a minute. Okay, so there is a force that is equal to the weight, and this is also equal to mg. It is acting in the downward direction. Okay, so therefore it will, to lift it to a height h. Therefore, we need to apply a force equal to the weight of the object in the upward direction. Okay, so a force is required on this mass in the upward direction equal to the weight, so that we can make the object move without any acceleration. Okay, so that it does not experience any net force. So we need to apply a force equal to the force of gravity, so that no net force is acting on this mass. Right, so now I am applying the force F, which is equal to the weight. It's very important to understand how it is working. So this force is making this object move, and it has displaced. What will be the displacement? The displacement will be equal to the height h. Right? So if I compute the amount of work done, the amount of work done is given by force into displacement. Right? Force into displacement. I must apply a force equal to the gravitational force, which is the weight mg, and the displacement here is h. So therefore, work has been done as mgh. I have done some work on the stone. Okay, so my work is getting converted into energy, and whatever work I have done, that is stored here in the stone in the form of potential energy. Okay, therefore, same amount of work can be done by the stone at any point of time. At any time, the stone can do the work, which will be equal to the mgh. Right? So hence we can say that the work done by us will be equal to mgh, and this is also equal to the potential energy of this stone. Okay, so this is the formula of gravitational potential energy. Okay, you can treat it as a formula. So this is the formula of gravitational potential energy. So anyone is thinking of any doubt, anything is not clear in this? Prince, any doubt?
No, sir.
You see. So the gravitational potential energy, its formula is, what is the formula of gravitational potential energy then? Siddharth? Siddharth, what is the formula of gravitational potential energy? Yeah, Siddharth, we have just computed. So what is the formula of gravitational potential energy? Siddharth, are you able to speak? The formula of gravitational potential energy is mgh. Okay. So a work done, or it has the gravitational potential energy which is given by mgh. Okay. So I hope keeping this in mind, we can have a question. Let us try to answer this question. You will have a few questions. We will have 2 to 3 questions. Just we'll measure them and let's see. A mass of 5 kilogram is lifted to a height a mass of 5 kilogram is lifted to a height of 10 meter. What will be the potential energy of the mass? Okay. So I think you can compute it easily and get me the answer.
Ma'am,
Whoever,
sir, can we take it the
Hmm?
gravitational force is 10?
No, we have to take it as 9.8. If it's not stated, we take it as 9.8 only.
490 Newton meter square.
Newton meter square or Newton meter?
Square.
Hmm.
No. It's 490 joules. Just simply.
Hmm. Okay, so let's see. It will be either Newton meter or you can call it a joule. Both are same. So I think everyone has understood, everyone has got the answer. Okay, let's see another question. A girl of mass for 35 kilogram climbs a rope of height 8 meters in 10 seconds. So what is the work done? What is the work done by the girl? So what is the work done by the girl? Okay. So these are the two questions. Do them quickly. Okay. So someone is sending the answer. Pranaya has sent the answer, and I don't think Prince, you are not sending any answer. Yeah, Prince.
Yes, sir, I'm sending.
Sir, I have a doubt.
Okay.
In the
So what are
second
the,
question, sir,
yeah.
are we supposed to ignore the time or
Is there anywhere requirement of time for using the formula of potential energy?
no,
If you
sir?
are using, no, then why should we take time then? No use. So if you see the first question, in the first question, let's say the answer number one, you have a mass of 5 kilogram, and that mass of 5 kilogram is lifted to a height of 10 meter. Okay. So we write here mass, which is 5 kilogram. The height given to it is 10 meter, and we know the value of G, which is 9.8. So now we can compute the value of potential energy. The potential energy will be given by the formula mgh, and this must be equal to
So
5
490
times, yeah,
490.
490. Okay. So this is your 490 joule. Either you write it Newton meter or this is as joule. Both are same. Okay. For the second question, this is the second question. For the second question, you have a girl of mass 35 kilogram. So for the second question, the potential energy is given by mgh. Here m is, this is answer number 2. Mass is 35. So therefore you get the formula mgh. Substitute the value as 35, multiply height 8 and multiply 9.8. Okay. So Rikshit, did you get the answer? Rikshit? Rikshit? Rikshit, are you able to speak? Can you unmute yourself?
So for second question, they asked the work done, right?
Yeah.
So isn't work done force into displacement?
Okay. So how much force does the girl has to apply?
Force. Force equals to mass into acceleration. But
Force
then
equals to mass into acceleration. Okay. Then,
acceleration is v minus u by t, but there's no v and u given.
okay. So see, okay. When the girl, suppose, okay, this is the a rope of height 8 meter. Okay. And the girl is here. She wants to climb this rope. Okay. If the girl has a mass of 35 kilogram, okay, So what is the force that is acting on the girl? Its weight mg, which is acting in the downward direction. Harini?
Oh, yes, sir.
Okay. So she must apply a same amount of force in the forward direction so as to be able to move in the upward direction, and hence the upward force required will be equal to mg, and it has to make a displacement of 8 meter.
Yes.
Okay. So the work done will be equal to mgh, force into displacement.
Yes, sir.
Okay. So that is what we said, that work and potential energy, they are equivalent. They are same.
Oh, okay, sir.
Okay. So when you are computing the potential energy, it's actually the work done. Okay. So any doubts? I think everything is clear up to here. Okay. Now let's see the other form of energy, another form of energy that we have to discuss, that is the kinetic energy. So we have to discuss the next one, that is kinetic energy. This is also a form of mechanical energy. So kinetic energy, it is the energy possessed by an object. It is energy possessed by an object energy possessed by an object due to its motion. So if an object is moving, right? If an object is moving, it must have some kinetic energy. It must have kinetic energy, and the kinetic energy of the object, it depends on its motion. So any moving object, it has some amount of energy. That means it has the ability to do work. Okay. Let us try to understand this. How does a moving object has an ability to do work? Okay. So suppose you have a ball, you place a ball at a certain point. Suppose I place a ball over here. So this is a ball of mass m. Now I strike this ball with another ball. I have another ball over here. So I take another ball. This is another ball of mass m. So suppose this second mass, let this mass be m1 and let this mass be m2. So I had m2 was at rest. Okay. So m1, when it was coming with certain velocity v, it comes and strikes this mass m2. So therefore m2 will start moving. Hence we can say, since the earlier m1 was moving with certain velocity, it has the ability to do work. Therefore, it displaces the mass m2 from its original position. Okay. So therefore it has some energy. The moving object had some energy, and hence it has displaced the other mass. You can also look for various other examples. For example, if you throw a ball on a window, on a glass window, if you throw a ball, so what result do you expect? Yes, Siddhisri, what result do you expect?
Okay.
Yes, Siddharth,
Sir, the window will break.
the window will break. So can I say that some work has been done by the moving ball? Yes, some work has been done by the moving ball. Okay, so therefore a moving object has an energy, and that energy is measured by its motion. Okay, so this kinetic energy, it is measured as, kinetic energy is measured as the formula of 1 by 2 mv squared. This is the formula of kinetic energy, where v is the speed of the object. Speed of object, the speed with which the object moves. Okay. So kinetic energy of an object is given by 1 by 2 mv squared. So understood? Now let's try to compute this. Let's try to solve this question. So you have a car of mass 20,000 kilogram, moving with a speed of 60 meter per second. So you have to tell what is the potential energy of the car. Okay. No, let the speed be 60 kilometer per hour. Not 60 meter per second, it's 60 kilometer per hour. And compute your speed. Okay. So find out the answer to this question. It's quite easy.
Sir, done, sir.
Done? Prince, have you done? Siddharth, if you have done, send the answer through the chat. Abhinav, Harini, Prince. Send the answers if you have done. Okay, so I up to now I have received 3 answers, and all the 3 answers are different. Okay, Prince has sent the answer, Siddharth has sent the answer, and all of them they are different. Harini, I have not got your answer.
So 1 minute.
Rikshit, are you there? Siddhisri, are you there?
Yes, sir.
Okay. Rikshit, what about you? Rikshit, we know that, and that is also a different answer. Okay, now let's see who is getting the correct answer. Let's see. So the formula of the kinetic energy over here, the kinetic energy is given by the formula 1 by 2 mv squared. Okay. So for this we need 1 by 2 multiply mass, which is 20,000, and multiply v square. But velocity v is given in kilometer per hour, so we need to convert it to meter per second. And the 60 kilometer per hour to meter per second would be 60 multiply 5 by 18.
16.6.
Okay, see. So the velocity over here will be 60 multiply 5 by 18. Simplify it. You get here 10. Here you will get 3. So you get 50 by 3. Okay. So put here 50 by 3 whole squared. Okay. Cancelling this, you get here 10,000 multiply 2500 by 3. So again, collecting all the zeros, you can write here 25 by 3 multiply 10 to the power. You have 3, 4 plus 2, 6 joule. And 25 by 3, you can convert it to decimal, which would be 8.33. So 8.3 times 10 to the power 6 joule. This is the amount of kinetic energy possessed by the car. So if I compare all your answers, so I do not find any of them equivalent to this. So just yes.
Over here, 50 by 3, we can take it as 16.6 and then we can square it, which would come around
256.
256. No, wait, I got something else. I got 275 and then 0.56. And then I multiplied it with 10,000, and then I got 2755600 joules. Like, I got it like that.
Okay. Okay, sorry. One thing. No, this is also not correct. This is divided by 9. 3 will also get squared and it will become 25 by 9. And I think it will be the same as Pranaya that got. Okay. So if you divide this 25 by 9, you will be getting here 2 point something. 2.75, right? Divided 25 by 9, you get 2.75 times 10 to the power 6 joule. Okay. Now let's see another one. We'll do a number of questions from this kinetic energy. Not to panic. If you have not got the correct answer, not to panic. You will get your answer correct in this question. Okay. So see, a car and a truck are moving with 45. Fifty-four kilometer per hour and 90 kilometer per hour. If the mass of truck if the mass of truck compute their kinetic energy. So I hope you have got the question now. So compute and compare their kinetic energy. Okay, whoever gets the answer, share your answer in the chat again. Your first step is you have to convert the velocity into meter per second and then use the formula of kinetic energy. Abhinav, what's the formula of kinetic energy?
Half into mass into velocity square.
Okay, half into mass into velocity squared. Pranay, convert that to scientific notation. Convert that answer to scientific notation, and then also tell which one has a greater kinetic energy.
Like the one with the more mass has more kinetic energy because mass and kinetic energy both are directly proportional.
So what about the speed? They are having okay. I have given you speeds as 54 and 90. Hmm. Okay, fine. Actually, I could have done the speed of I wanted to give the speed of car as 90. Okay, okay, no issues then. So see, let me solve this. I think Prince, have you got the answer?
Sir, yes, sir.
Okay. See, the kinetic energy of car, G of car will be given by 1 by 2 times of m, which is 20,000, multiply v squared, which is 54. So converting this v square, this would be converted to 15 meter per second. Okay. So are you getting this 15 meter per second? 54 into 5 by 18. This is your 15 meter per second. Okay. Then convert this 90. You get 25 meter per second. So put here value which is 15 squared, and you can directly get your answer, which is 225 times 10 to the power 4, and hence you get 2.25 multiplied 10 to the power 6 joule. Okay. So we'll continue with this in the next class. I hope everyone has understood. However, I was not getting answers from all of you, but I will be sending a few questions just for your practice. Okay. Bye everyone. Good night and see you all.
Thanks, Sebastian.
Sir,